Hello children, so today we are going to start a new chapter, motion in a plane, or we can say motion in two dimension. Just before, till the last session we have studied motion in straight line, motion in straight line. Same chapter we name as this also, one dimensional motion. One dimensional motion. You might be remembering we dealt either horizontal motion, we have dealt vertical motion also. So either x or y, either x direction, either displacement, distance, velocity or acceleration. All these changes, all these physical quantities will change either in x direction or in y direction. We did not consider a case where both x as well as y, both will change. So a car is moving like this, all changes are in x direction. A balloon is alighting like this, this is also y direction, only one. Suppose something is moving in this direction, just like this, or circular motion. If it is moving like this, we can say one side y is also changing, another side x is also changing. So this type of motion we are going to study in this chapter. Clear? You understood the difference? So instead of motion in straight line, here we will be studying motion in plane. Motion in a plane. Motion in a plane means this board is a plane. Board is a plane. We draw x-axis and y-axis in a plane. Something is moving like this. We can say x is also changing, y is also changing if something is moving like this. Clear? So we call the motion in a plane or two-dimensional motion. Two-dimensional motion. So need not think that one-dimensional motion had its complexities, so two-dimensional motion will be very complex. No. So we have our forefathers, all genius people, scientists, all people who study physics, they have made some techniques, they sit and worked and made certain things in order to make the study of this easy. So this chapter is broadly divided into mainly three topics. I will tell that. So the new chapter's name is motion in a plane. Motion in a plane. So this chapter is divided into, first one is vector basics. Vector basics. Number 2, projectile motion. Number 3, circular motion. So these three topics, major topics, we will study in detail. So first we will study about vector basics. In one-dimensional motion, we have classified displacement, velocity, acceleration, force. All these we have mentioned that they are vectors. They have direction. You might be remembering all this. So when we deal into more physics, two-dimensional motion in a plane and all, with the help of vector, we will be able to solve those problems easily. If you don't understand and study, you may feel like this is very difficult. Okay, just if without understanding, if you look at vectors, whatever written, everything, we will feel uncomfortability. But if you understand and learn, this is easy. Why vector is made? Vector algebra is made in order to make our things easy. So we will study with the basic fundamentals. Clear? So today we will start vector basics. With the vector basics, okay, remaining full physics, okay, remaining full physics, this vector will come. Okay, so this understanding is very important. Basic understanding of this make our study very easy. Okay, so sit and study carefully. Take pen and paper, book, everything ready, and concentrate. Wherever you don't understand something, pause, see that again. Okay, sure, we will start. Okay, so all physical quantities, okay, everything we discuss in physics, we can classify into two categories. Okay, all physical quantities. All physical quantities we can classify into scalar, then vector. Okay. Scalar is something which has only magnitude. Magnitude means what? A number or a size. Example, if we say 2 kg apple, if you go to a shop and say 2 kg apple, we said 2. That 2 is what is magnitude. We said kg, that is nothing but unit. The shopkeeper doesn't know you are asking 2 tons of apple or 2 kg. So kg we will be using, that is unit. Just 2, the number, that is what is magnitude. So scalar are physical quantities which has only magnitude. Vectors are physical quantity which has got magnitude and direction also. Okay, see. Someone punched. Okay, I punched. Someone can ask in which direction he punched. Correct, no? Okay, in this direction I punched. Okay, someone moved. We can ask in which direction he has moved. Okay, so direction and magnitude both will be there in vector, but in scalar only magnitude, no direction. We will say the temperature of the day is 29 degrees Celsius. 29 degrees Celsius, that's it, over. We won't ask like 29 degrees Celsius in which direction. Okay, if we measure, if we use a thermometer here also, here, all these places, temperature will be same. Temperature will not move in a particular direction. Okay, so scalar example is what? Temperature. First we will write it has only magnitude. Only magnitude. Magnitude means what? Number or size. Okay, some example 2. Okay, some number. Okay, this is first point. Vector magnitude is there. Okay, another point is direction is also there. Okay, so vector has both magnitude and direction. So what is the example we can give here? Example, temperature. Temperature. Okay, example of scalar. Here we can write force. Okay, what is the examples we have seen in motion in one dimension? We can say displacement. Displacement has direction. Okay, velocity. Okay, velocity, all these. Here, other than that, what we can write in the place of displacement? Distance. Okay, distance is scalar. Speed. Okay, speed is also scalar. Velocity. Here we can say acceleration. Okay, so all these are examples of scalar and vector. Note it down. Third point, we saw what is the basic difference between scalar and vector. In difference itself, the third point is scalar obeys linear algebra. What is it? I'll explain. Okay, here it will obey vector algebra. Okay, linear algebra. Just if we say 2 plus 2, 4, 2 plus 3, 5, 2 into 3, 6. Okay, your primary school mathematics. If we need to add two vectors, okay, if we need to add 3 degrees Celsius to 5 degrees Celsius, simply it is 8 degrees Celsius. That is what is linear algebra. It is not something new. Okay, whatever you have studied, we have studied, I have studied in primary school mathematics, that is what linear algebra. Okay, simply we can add, simply we can multiply. What about this? This obeys vector algebra. This is vector algebra. Okay, what is this vector algebra? This is what we are going to study. In vector, 2 plus 3 need not be equal to 5. Clear? 3 plus 3 need not be equal to 6. All it depends on the angle in which they are acting. Suppose I said already they have direction. So if this is 2, if this 3 is 2 is acting in this direction, 3 is acting in this direction, 2 plus 3 will not be equal to 5. All depends on the angle also. Whatever angle is here, all this depends on the angle also, because direction is there. In scalar we said 2 into 3 is 6, but in vector 2 into 3 is not 6. Need not be 6. It can be, but it has a different technique. So if we understand, if we study vector algebra, then no problem at all. If someone come and ask you what is 2 plus 3, you will say 5. Why you are asking such silly questions? You will be asking. Why? Because you have studied linear algebra in our school. Now if we don't study vector algebra, things will be very difficult. But if we study how to deal them, then things will be easy. Okay, so without studying this properly, if we go to some topics in physics, okay, it will be so hot, we won't be able to touch. Okay, without this proper basics, that is the reason we say physics is tough. Okay, so in +1 itself and in +2 topics, in many places vector will come. Without studying this, we cannot survive, we cannot study physics. So we will try to make it interesting. Okay, so understood now the importance of vector algebra. So again, just like in primary school we have studied what is addition, what is subtraction, what is multiplication, all these things based on vector we will study. After that we will do some problems also. We will make it comfortable, then we will start the topic of motion in a plane. Clear all of you? Okay, so linear algebra here, vector algebra there. Okay, so certain things, certain physical quantities appear like they will have a direction, okay, but we will be able to solve them using linear algebra itself. So that they are also what? They also can be considered like a scalar. Okay, certain things we may feel like no direction, but it may have direction. We will have to consider them as vector. Okay, so what do you think about current? What do you think about current? Suppose, okay, we have studied in 10th class, no? In 10th class, current electricity is there. Okay, if 1 ampere current is coming like this, 2 ampere current is coming like this, they will join and go as 3 ampere current. Okay, this is a part of circuit. Full circuit cannot exist like this. Okay, so 2 ampere is coming, 1 ampere, 3 ampere. So what about current? Current is a scalar or vector. Okay, what do you feel? Okay, so it seems like current has direction. Current is moving in a particular direction and it is joining here. Okay, so current is a vector. Okay, just see, if we 2 ampere and 1 ampere, if we take 2 ampere plus 1 ampere is equal to 3 ampere. This is just primary school mathematics. Okay, so see, if we take, instead of a line like this, suppose if we change the direction of this branch or this segment like this, then if this is 2 ampere, if this is 1 ampere, what is this is going to be? Still this is going to be 3 ampere, whether I make it in this direction or even if I change to this side, again this is going to be 3 ampere. Okay, so even though we feel like current has got direction, current is simply obeying linear algebra. Current is simply obeying our primary school mathematics, just 2 plus 1 is equal to 3 ampere. If current was following vector algebra, definitely what is this angle, direction, everything we would have considered. So we can say current is a scalar. Current is a scalar, and since current has got direction also, it is a matter of discussion, no? Direction is there, but it is not vector, it is not following vector algebra. So just because of that reason, current is also considered as tensor. Okay, current is also considered as tensor. The correct term is current is tensor, but we don't study about tensor in our syllabus. We don't have that. So current is but called as tensor, but current is a scalar also in the terms that this is not obeying vector algebra, but current is just obeying linear algebra. Clear? Just for your understanding, I told this. Now, when we study about vectors, we use a coordinate system. Coordinate system is nothing but we used to draw our graph in x and y axis. So this x, y, in addition to that, in order to address the 3 dimension, we will be using z also. So that is what this coordinate system x, y, z axis we will use, and we will use the same system in order to address vectors also. Okay, so if this is x, if this is y, z should be like this, correct or what? Z should be like this. Z should come to you or away from you, going inside. Okay, so negative x-axis is this, na? And negative y-axis is this. Likewise, we have z also, and we will have negative z axis also. Okay, so this one, if I bend, it will be coming towards you. Okay, so x, y, z. So using this x, y, z only, we will be addressing our vector. Clear? So graphically, while showing vectors, we will be drawing line with the arrows. Suppose if I draw like this, okay, this is head, and this is head, and this is tail. This is how we address vectors, okay, graphically while drawing, right? Tail and head. So when a head is pointing towards which direction? Head is pointing towards which direction? That will be the direction of vectors graphically. Clear? Okay. There are various types of vectors. Okay, we will just see about the types of vectors. Slowly we will get into the basics. Okay, thorough discussion. See, if we need to study about something, we need to discuss about it. Continuous discussion will make it very close to the subject. Okay, so we will study about the types of vectors. Types of vectors. First one, we will see collinear vectors. So collinear vectors is nothing but, if I draw a vector like this, okay, suppose if its magnitude is 10, I can draw another vector, okay, this is also in the same line, but its magnitude is 2. Okay, these two are collinear vectors. Okay, vectors in the same line. Vectors in the same line. Vectors in the same line. If I need, I can have a vector in the opposite direction also. This is another vector which magnitude is 1. All these are collinear vectors. Number 2, coplanar vectors. Coplanar vectors are nothing but vectors in the same plane. Vectors in the same plane. Okay, or suppose if this whiteboard is a plane, so a vector is here. Okay, this is one vector, another vector in the another direction, but this is also in the same plane. Okay, now if I take another vector in this direction, okay, so all these are coplanar vectors because they are in the same plane. Now if I consider this marker as a pen, marker as a vector, and if I keep it like this, is it a coplanar vector with these vectors? No. This vector, if this is its head and this is its tail, is it coplanar vector with this vector? No, because this vector is in this plane. Okay, this vector is in this plane. These vectors are in this plane. So coplanar vectors, hope you understood. Number 3, parallel vectors. Parallel vectors, nothing, just if this is one vector, another vector is also going in the same direction, magnitude need not be same. This is 10, this is 5, but these two are parallel vectors. Okay. Another one, 4. equal vectors. Equal vectors. All these classifications, this is important. Sometimes a question can come. Okay. Equal vectors. Equal vectors is nothing but, suppose if I draw one vector here, its magnitude is 5 units. I draw another vector here. This is also what? 5 units. Whichever direction it is pointing, same direction this is also pointing. So these both are equal vectors. If I need, I can draw another vector, okay, like this. This is also 5. This is also pointing in the same direction. So all these are what? Equal vectors. They must be in the same plane and they must be going in the same direction also. So vectors with equal magnitude and same direction. Equal magnitude and same direction. They are all equal vectors. This is very important. This is very important. This shows that I can place this vector anywhere. I can place this vector here, 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 anywhere. Okay. Vector I can place anywhere. Only condition is I should not change the direction. I should not change the magnitude. Okay. This is very important, dear students. Please understand that equal vectors I am stressing here because I will be using it today itself. Okay. Its magnitude and direction is same. Okay. Anywhere I can place the vectors. I should not change the direction and magnitude. Clear? Fifth one, unit vectors. Unit vectors. This unit vector concept is very, very, very important. Okay. First I am giving a small introduction. After that we will discuss about unit vector a little more detail. Okay. So unit vector is nothing but vector to show direction. Vector to show direction. Vector to show direction. Okay. That is just like a signboard. Suppose if you are moving through a route, if you are moving in a road, there will be signboard. Okay. Right towards Coimbatore, straight E road, this side Palakkad, likewise. The purpose of that board is nothing else. It is not to give shade to the people. It is not to give any other comfort. That signboard is just to show direction. So that is the purpose of unit vector. Unit vector is just to show direction. Okay. Its magnitude is, okay, so 1, number 2. Magnitude of unit vector. Magnitude of unit vector is 1. What is magnitude? Magnitude means the number, size, or the how much we ask. So this unit vector is just to show direction. So its magnitude should be 1. Okay. I will show you. Suppose when we draw x, y, z, someone punched in this direction. Okay. So I punched with 5 Newton force. 5 Newton force. The punch, okay, a punch in this direction, this was 5 Newton. So when I write 5 Newton, okay, I wrote force is equal to 5 Newton. When I say force is equal to 5 Newton, it just shows us how much is the force. How much we can read from that. Unit is there, that is other thing. 5 is the force. So when we write 5 Newton, okay, suppose if I am punching in this direction, this is actually force. If I am pulling someone, this is also force. So when we write 5 Newton, we don't have any idea whether the punch is in the left direction or right direction, or in north, south, east, west, x, y, z. That is what I am telling is, we have different ways to mention directions. Some people used to say go north, turn south. You can see old age people used to tell, okay, in country areas and all, they used to say go north then turn south, you can see the house there. We might not have any idea where is north, south and all, okay. Or otherwise people used to say go straight, turn left, then right. Most of the roads, when they tell us the way, this is how. Now in coordinate system, we are using a method x, y, z. So when we mark x, y, z, suppose if I am punching in this direction, if I write 5i, force is equal to 5i, then we will get an idea. The magnitude of force is 5 Newton. At the same time, the direction is in I direction. So we will get that idea. I means x. So the unit vectors which is used to denote x, y and z. For x direction we use I, y direction we use j, z direction we use k. So suppose someone is moving 5 meters in this direction, in the x direction. So we can say, if we write 5i, then it is well understood that the displacement or the position is 5i. Someone moved in this direction and we wrote 3j, means displacement is 3j. Someone moved in this direction. In this direction means that direction, okay, towards you. We say, okay, this is 6k. Okay, so along x direction, if we say 5, we will not have any clarity whether x direction or y or z. Okay, so likewise we can say 5, if we say 5 meters, we don't have any idea which direction. If I write 5i, we will get an idea, oh, the displacement in or distance is in which direction? X direction. Aptly say displacement, because displacement is vector. So 5i, that is nothing but 5 meters in x direction. Okay, 5j, 5 meters in y direction or upwards. Then 6k someone is saying means towards you or away from you, likewise. So this is called unit vectors. Unit vectors are to show direction. So I to show x direction, j to show y direction, k to show z direction. Okay, clear? Do you understand what is the need of unit vectors? Just to show direction. Okay, now I said I is to show x direction, j is to show y, k is to show z. But we cannot say all the vectors must act in x, y, z. There are other directions also. Correct, no? If someone is punching, he doesn't need to punch always in x direction. Or some particle is moving upwards. The particle can move in any direction. So what we will do, if there is a direction like this, if this is y, this is x, someone has moved in this direction. Someone has moved in this direction. So how we will denote this direction? How we will denote this vector? We can do one thing. This is 2, no? In which direction? X direction. So 2i. If we extend this, what is this? This is also 2. In which direction? Y direction. So 2j. So this vector, suppose if this is displacement vector, this displacement vector is nothing but 2i plus 2j. So the unit vectors, if we write unit vectors, we will put a cap. For denoting vectors, we will show arrow like this. Now, in this direction, someone has moved. From here, if someone has moved in this direction, see, in this direction now, x also changed, y also changed, z also changed. So suppose someone has moved in that direction. How we will show? 3i plus 4j plus 2k. Okay, 3i. Okay, 4. Suppose if we put 4j. Now 2k, 1, 2. Now this is the direction of movement, position of something. Suppose if this is a b is flying and b has came and b has staying here now. Now here the b is staying. Suppose if this is a b, this is staying here. Now someone is asking, with your coordinate system, what is the position of that b? Okay, b is here. So what should I do? I will be taking the height. So height I got as 3. So 3j I got. Okay, b is here. Okay, now I will be measuring 1, 2, 3, 4. Okay, 4. I am getting around 4. Okay, 4x is there. So I will be writing 4i plus 3j. Now it is here. So 1, 2, 3, 4. 4k. So I will say that is the position vector of b. Position vector means where that b is standing. Position vector of b. So position vector is a vector, displacement is a vector, force is a vector, velocity is a vector. So all these things we can address like this. Okay, so I, j, k, all these things are new for you, but after continuous usage of this we will be comfortable about this. Okay, so this is how unit vectors. Now how to find unit vector? What is unit vector? Unit vector is nothing but the vector showing only direction. Magnitude will not be there. Suppose if we get a vector like a vector a is 2i plus 3j plus 4k. Now this is vector. Unit vector means its direction. I don't want its size or number. I just need direction alone. So how can we find a direction? A formula is there. Unit vector. In order to find unit vector, what we need to do? We must divide the vector with its magnitude. What is this sign shows? This modulus sign is nothing but magnitude. How to find magnitude? If a is this, root of 2 square plus 3 square plus 4 square. So root of 4 plus 9 plus 16. So root 29. So if we need to find unit vector, what we need to do? 2i plus 3j plus 4k divide by root 29. This is what is unit vector of this vector. There, note it down. Everything, please note it down. Suppose unit vector is nothing but vector a divided by mod of vector. Now suppose a is equal to 2i. What does it mean? A magnitude of 2, any vector, whether it is displacement, velocity, doesn't matter, which is acting in the direction x direction. What is its magnitude? Vector a is what? Mod of vector a is what? What is its magnitude? 2. 2 is its magnitude. Correct, no? Suppose a is nothing but 2 Newton, which is acting in I direction. Hey, this is force only. So magnitude a is equal to 2. What is the direction of a? That is, what is the unit vector of a? What is the direction of a? direction of A is nothing but I. I is what is showing the direction. So in order to get unit vector, what we have done? Vector A divided by mode of vector A. What is vector A? 2I. What is mode of vector A? This is nothing but 2. We get I. Clear? Since this is a single term, we understood it easily. Suppose A is equal to 2I plus 3J. Now simply we cannot say I and J is the direction. I and J is mixed here. Okay, direction will be like somewhere in between. Okay, see, 1 2 3 1 2 3. So 2I plus 2I means here, 3J means here. This vector is acting in this direction. Okay, 2J. Correct, graphically. Now how to find unit vector? Vector divided by mode of A vector. So what is vector A? 2I plus 3J divided by mode of A is nothing but 2 square plus 3 square. Okay, so this is going to be 2I plus 3J divided by root 4 plus 9. So 2I plus 3J divided by root 13. Okay, here we have directly divided with 2. What is the problem here? Why can't we divide with 2 and 3? So we cannot do that. We need to find the modulus of 2 and 3 here. How this formula came, all these things we will study later. Okay, just I am directly telling you some formulas. How these things came, we will study. Clear? Now suppose if we take another example. Okay, here vector A is equal to 2I plus J plus 4K. What is its unit vector? Vector A divided by modulus of vector A. So 2I plus J plus 4K divided by root of 2 square plus 1 square plus 4 square. So this is 2I, everywhere cap must be there. 2I plus J plus 4K divided by 4 plus 1, 5, 5 plus 16. Okay, so this will become 21, root 21. Because this is the direction of the vector. We are just dividing with its magnitude. Finding the magnitude only, this formula we are using. Okay, I will generalize and give. Clear? Note it down. Suppose if vector A is equal to, simply generalizing, AXI plus AYJ plus AZK. These are the components in XYZ direction. Now if we need to find unit vector, what we should do? AXI plus AYJ plus AZK. Simply we should write the vector as such. Divide by root of AX square plus AY square plus AZ square. So this is the general formula for finding unit vector. Okay, clear? So here there is a question. The question is nothing but check whether the vector, this is the vector, is a unit vector or not. Okay, this is a unit vector or not. How to check this? Okay, so if unit vector, if A is equal to, suppose if we put A is equal to I by root 2 plus J divided by root 2. So if this is a unit vector, the magnitude of A must be what? 1. Okay, so how to find the magnitude of A? So this is nothing but, this vector is nothing but 1 by root 2I plus 1 by root 2J. If we write separately, you will be able to differentiate it easily. How to find magnitude? Ax square plus ay square. K term is not there or z term is not there. So what is ax here? 1 by root 2. 1 by root 2 all square plus. Here also ay is also 1 by root 2 the whole square. So what is happening? 1 by root 2 all square is what? 1 by 2. This is also 1 by 2. So root 1 is equal to what? 1. So this is a unit vector. Clear all of you? To find unit vector, the magnitude of unit vector is always 1. So we just found the magnitude of this vector, okay, just by using this formula. So that answer is 1. So since the answer is 1, this is a unit vector. Now listen students, suppose if a vector A is equal to 2i plus 3j. Okay, I am just plotting this vector here 1, 2, 3, 1, 2, 3, 4. Now suppose A is equal to 2i plus 3j. A is equal to 2i plus 3j. So this is 4, this is 5. 4, 5. Now suppose 2i plus 3j. How to draw 2i plus 3j? Here in the board. 2i means here, 3 means here, j means in this direction, 2 means in this direction. So wherever it is crossing, we can mark this, and this is what is the vector in this direction. Clear? 2i plus 3j. Suppose if I am multiplying 2 into vector A, this is vector A, 2 into vector A. So this will become 2 into 2i plus 3j. That is, this 2 is a scalar number or simple number. If I am multiplying a scalar with a vector, what will happen? Okay, this is a scalar. So this will become 4i plus 6j. 4i plus 6j. Now suppose if this is 6, if I need to draw this vector, then how can I draw? 1, 2, 3, 4. So this is the x component. 6j means here it is. So here it is going to be. So now if I draw this vector, this is what is 4i plus 6j. Clear? Likewise, if I multiply, I can increase the magnitude. Direction is same. Clear? Likewise, we can play with the vectors. So this is scalar into vector. Okay, how to multiply scalar into vector? So multiplication of scalar with the vector. Okay, note down. See this question. If A is equal to 4i plus 3j, if vector A is equal to 4i plus 3j, vector B is given as 24i plus 7j. Okay, that is the magnitude, direction, everything we can see. Find the vector having the same magnitude as B and parallel to A. Getting the question? Find the vector having same magnitude as B and parallel to A. So what they are asking is, we should find a vector, okay, which should have the magnitude of B, parallel to A means direction of A. So what we should do? We should find the magnitude of vector B and multiply or put the direction of vector A to the vector. So just see, magnitude as B. So first we will find the magnitude of B. So what is B? 24i plus 7j. So this is going to be 24 square plus 7 square. So when we do this, what we will be getting? 24 square plus 7 square, we will be getting root 625. Root 625, which is equal to 25. Okay, root 625 is nothing but 25. So magnitude we got. Now we need the vector parallel to A. So parallel to A means direction of this vector must be the direction of A. Direction of new vector must be direction of A. So first we will find the direction of A. How to find the direction of A? Just by finding unit vector. So A cap is nothing but magnitude of A divided by, vector A divided by magnitude of A. Okay. So what is vector A? 4i plus 3j divided by, how to find magnitude of A? 4 square plus 3 square. So this is equal to 4i plus 3j divided by the 16 plus 9 root 25. This will be equal to 5. Okay, so magnitude of B is ready, direction of A is ready. Now suppose if vector C, we just assume that vector C is the answer. So vector C, finding the vector, okay, any vector C is equal to magnitude of vector B into direction of vector A. Okay, magnitude of B parallel to A means direction of vector A. So what is this? Magnitude of vector B is 25. Direction or unit vector of vector A is this. So 4i plus 3j divided by 5. So this 25 will be cancelled off. This will be 5. Okay, so when you multiply 25 magnitude of B into unit vector of A, so this 525 cancelled, 5 into 4i plus 3j, if you multiply inside we will be getting 20i plus 15j. So students, parallel to vector B, vector A means direction of vector A. Magnitude of vector B means we need to find magnitude of vector B. Okay, so this question will make us understand what is unit vector, how to find a new vector, putting the direction of some other vector. Clear, I think. Okay, see students, vector algebra is considered as little bit confusing and little bit tough. The reason is, when it appeared to us, when we start studying vector algebra, lot of new things, new kind of terminologies, lot of new signs, symbols will come. So we will get a little bit afraid. Okay, you should not worry. Okay, we have just started. Whatever we discussed here, we are going to repeat again and again in the coming sessions also. Okay, so by continuous discussion you will become thorough and you will become comfortable. Your responsibility is, whatever we have discussed today, just go through that, just read through that, and definitely every discussion in one-to-one teaching, okay, 100% we will never understand. 100% understanding we will get when you ask doubts. Okay, so we will discuss further. You can ask doubts. Okay, we again and again we will discuss. So your vector basics will be thorough. Okay, in vector you will be very comfortable. Then only we will move to the next topic. So you just go through that. Okay, and ask, come to me with the doubts. Again we will discuss. Okay, through continuous discussion we will become comfortable, I hope. Okay, so what all things we have studied today? We have studied what is just vector and scalar. What is the difference? Scalar means only magnitude. Vector means magnitude and direction. Scalar means addition, multiplication, everything follows just linear algebra or primary school mathematics. Vector algebra means we have to study. Okay, that we have not started. Vector addition, vector multiplication, nothing is started. What is vector? That is only we are discussing now. Okay, just we should get a feel of vector. No, that is why we have discussed all that now. Then we discussed the different types of vectors. Collinear vectors, vectors in the same line. Coplanar vectors, vectors in the same plane. Parallel vectors means vectors that are going in the same direction but it can have different magnitude. Equal vectors, vectors with the same magnitude, same direction. Wherever we place. In the plane we can place here, here, everywhere, anywhere we can place. Although all of them are same vectors if the magnitude and direction are same. Clear? Then we had a detailed discussion about unit vectors. Unit vectors are just to show direction. I, J, K are the unit vectors specifically for x direction, y direction, z direction. But a vector need not act always in x, y and z. It can act in any direction. So if it is in a plane means we will have to use x as well as y or sometimes z also. So 2i plus 3j, 4i plus 5j, these kind of vectors also will come where x direction also will change, y direction also will have some changes. Clear? So displacement, force, velocity, all these things we can discuss in vectors. Then how to find unit vector? Vector divided by its magnitude. How to find magnitude? Root of its components square. That is its magnitude. Okay, so vector divided by its magnitude. Okay, then parallel vectors means its direction is like that. We have done some problems also. So revise all these. Okay, no need to worry. Okay, when you see something new, it will be like that. Okay, go through it continuously and we will make everything ready. Again, we will continue with the discussion till we are comfortable with the vectors. Okay, students, goodbye, good luck.